So let's check ourselves on these recursive formulas. The first one, it gave us the sequence 12, 8, 4, 0, and negative 4. So we had to find our common difference. Well, 12 to 8, we subtract 4. 8 to 4 is subtracting 4. 4 to 0, we subtract 4. So therefore, our common difference is negative 4. Our first term in this case is 12. So therefore, when we write the recursive formula, we have a sub n minus 1. And our difference was minus 4. For the second sequence, we had 5, 11, 17, and 23. Our a sub 1 is 5. And now we have to find our common difference. Well, 5 to 11, we're adding 6. 11 to 17, we're adding 6. And 17 to 23, we're adding 6. So our common difference is equal to 6. So our recursive formula is a sub n minus 1 plus 6. Now let's look at the last sequence. Our a sub 1, so our first term is 98. Sorry about that. And now we got to find our common difference. So 98 to 88, we're subtracting 10. 88 to 78 is subtracting 10. 78 to 68 is subtracting 10. So our common difference is negative 10. So therefore, our recursive formula is going to be a sub n minus 1 minus 10. Now let's move on to our explicit formula, which is going to be our very useful form for arithmetic sequences. So our explicit formula, you can find any term at any time. We're going to use this to find any term in the sequence no matter where it's at. So you can find any term. This is really good. So if I ask you to find, let's say, the 54th term of a sequence, you guys don't want to sit there and let's just say your difference is adding 10 each time. You don't want to add 10 54 times. Instead, you're going to want an algebraic equation or an algebraic formula to help you find that 54th sequence in a little easier manner. So to find any term of an arithmetic sequence, we're going to use the explicit formula a sub n equals that a sub 1 plus n minus 1 times d. This is where a sub 1 is equal to the first term of the sequence. D is your common difference, and n is the number of the term that you want to find. So let's see here. We're using the same sequence as 5, 8, 11, and 14. We already know that our a is 5, and our common difference, we're adding 3 each time. So therefore, our difference is a positive 3, because I added 3. 5 to 8 is plus 3. 8 to 11 is we're adding 3. 11 to 14 is adding 3. So our a sub n in this case is going to be our a1, a sub 1, which is 5, plus n minus 1, because we have not defined what term we want to find yet, multiplied by our difference, which in this case is 3. Sorry about that. So because I have the 3 multiplied by this parenthetical statement of n minus 1, I'm going to use the distributive property. So I'm going to distribute the 3 inside. So I'm going to get a sub n equals 5 plus 3n minus 3. And all I'm left to do is to combine like terms. So my a sub n is going to be, so my like terms in this case are 5 and negative 3. And 5 minus 3 is 2. So I have 3n plus 2 as my explicit formula for the sequence. Now it's asking us to find a sub 6. So it's asking us to find our 6th term in this case. So anywhere I have an n in my explicit formula, I'm going to replace it with 6. So in this case, I have a sub 6 is equal to 3 times 6 plus 2. That means our a sub 6 is going to equal 3 times 6 is 18 plus 2. So therefore, the 6th term of the sequence is equal to 20. If I were to write that as an ordered pair, it'd be 6, 20. You guys try the next two.